Okay, this is going to be the walkthrough of 5.5 worksheet. Make sure to have a copy of your reference sheet. Number 1, if you remember, this is very similar to a linear equation. It has a number and it has only one variable, in this case theta. So what we're going to do is solve for all the solutions between this specific interval. Okay, first thing we're going to do is just solve it and isolate the theta. Subtract square root of 3 by both sides. Then you're going to divide by 2. So now I have cosine of theta is equal to negative square root of 3 over 2. If you want to take the cosine over to the other side, you can do that. But remember, you're not restricted to just quadrant 2 in this case, because cosine is negative. You want all of the solutions between 0 and 2 pi. So in this case, we're going to have 2 solutions. Okay, so we're going to go to where's theta when cosine is equal to negative square root of 3 over 2. As I said, it's going to be in quadrant 2 and in quadrant 3. Notice that this is also given to you in radians, so we're going to look for our radian answer. Negative square root of 3 over 2 is here, so our first answer is going to be 5 pi over 6. And then the second place is going to be here, which is 7 pi over 6. So that's how I get my answer for that one. Okay, number 2. Number 2 is also similar to a linear equation. You only have one theta. In the first part, all you're doing is you're using your sine or your cosine. Now we're going to be using the other 4 trig functions: tangent, cotangent, secant, or cosecant. So the first thing I'm going to do is isolate theta, subtract the square root of 2 on both sides, convert cosecant to 1 over sine, okay, and then solve for sine of theta, which I have here. Okay, sine is negative in quadrants 3 and quadrant 4, so I'm going to look on my unit circle. Here we go, 5 pi over 4 and 7 pi over 4. Those are going to be our 2 solutions. Let's go on to the next page. Okay, number 3, we're going to solve a trig function using sine or cosine, and this time we're finding all solutions. So notice that there's no restriction, so we want to find an equation, in other words. It has to be in terms of pi. That means we're going to be using radians. Again, it looks like a linear equation. All I'm going to do is minus 1 from both sides. Okay, and then cosine is only negative 1 when theta is equal to pi. Remember, cosine is your x value, so there's only one location. So in order for us to write the equation, we're going to find all coterminal angles where theta is equal to pi. So theta is equal to pi plus 2 pi times n. N will be any real integer, and this will be for all real solutions. Like if n is 0, then our answer is just pi. If n is equal to 1, we got 1 pi plus 2 pi, that's 3 pi. 1 pi, 2 pi, 3 pi, we end up in the exact same location, okay, and so forth. All right. Okay, for number 4, we're going to go ahead and find all solutions in the interval from 0 to 2 pi, and this is for a tangent. Notice that the 3 is not on the unit circle for tangent, so there's no other way but to use the calculator, and we're going to round to the nearest hundredths. Okay, tangent 3, all I'm doing is taking tangent to the other side. Make sure your calculator is on radian mode. Now, if you remember from unit 2, tangent is actually positive in quadrants 1 and quadrant 3. Okay, so the first thing we need to do is determine what our theta is. Okay, so I'm going to go ahead and do that. I'm going to do second tangent, and then I'm going to put a 3 in here. Okay, so here we go, 1.249. It does say to the nearest hundredths. I think I just did to the nearest thousands, because that's what my answer shows here, but that's okay. So this should be a 5. All right, remember, tangent is also positive in quadrant 3, so in order to go from quadrant 1 to quadrant 3, we must add pi. So remember here, let's just use this as an example. Tangent of 45 degrees is 1. If I add a whole 180 or pi, then I'm at tangent of this angle is also equal to 1. So these two tangent values are the same, and the way I can get there is by adding a pi or 180 degrees. So in this case, add pi, and I get 4.39, and that would be our second solution. Okay, number 5. Now we're going to go a little bit higher. Notice that this is very similar to factored equations. So we're going to go ahead and solve this in the interval of 0 to 2 pi. All you're going to do is set up this parentheses equals to 0, or this parentheses is equal to 0. Because remember, anything times 0 is just 0. First thing I did was this side. Now we have like a linear type equation. So we're going to add the square root of 3 to both sides. Okay. And then cotangent. Remember, cotangent is going to be positive in quadrants 1 and in quadrant 3. So I'm just going to go ahead and use my unit circle. Square root of 3. Remember, cotangent is going to be x over y. So when I'm going over here, I'm going to look at this one. X is the square root of 3, y is 1, and that's what I have here. So my first solution is going to be pi over 6, and the next solution would be 7 pi over 6. Okay. On this side of the equation, again, we're going to solve for x, subtract the square root of 3 from both sides, divide by 2. Okay. Sign is going to be a negative in quadrant 3 and in quadrant 4. So I'm going to look in my unit circle, and I'm looking for the negative square root of 3 over 2. Here's my first solution at 4 pi over 3, and then my second solution will be at 5 pi over 3, because that's my y value. Okay. All of these answers are between 0 and 2 pi. Number 6, now we have something that is in a quadratic equation type form, but notice that this is not the exact same thing as this. I'm going to go ahead and write an example. Here we have ax squared plus bx plus c is equal to 0. This is the standard form for the quadratic equation. Okay, and notice that we have a term that is squared, but we don't have another value. This b here is gone. That means we can use the square root property to help us solve for this problem. Okay, I'm going to go ahead and isolate x by adding 1 to both sides, then dividing by 3. So I have cotangent squared x is the same thing as 1 over tangent x, and all I'm doing here is I'm actually flipping it. Okay, so I have tangent squared x is equal to 3. If I take the square root of both sides, then this becomes tangent x, and then this becomes the plus or minus square root of 3. We're going to look for every single quadrant, okay, where tangent is the square root of 3. Remember, tangent is going to be y over x, so when I'm looking here, I'm looking for the square root of 3 over 1. Our first solution is pi over 3 for quadrant 1. For quadrant 2, it's going to be 2 pi over 3. Then we're going to have 4 pi over 3, and then finally 5 pi over 3. Okay, so now we have all of our solutions. Number 7, we're going to go ahead and solve all solutions in the interval. And this is a quadratic equation. It's in standard form. Okay, so what we're going to do is we're going to factor it out like we traditionally would. Okay, so this is going to be solved by direct factoring. The way that I normally do that is I will multiply the a and the c together, including the signs. So it'll be 1 times 3, 3. And then I'm going to find all the factors of 3 that I can. In this case, it's only 1 and 3. Now, notice that 3 is positive, and then over here you have positive as well. But because this is a negative term and this is positive, that means both of these signs have to be the same. So if I said 1 times 3 is 3, that is actually correct, but it's also correct to say negative 1 times negative 3 is positive 3. And since I want my b to add up to a -4, when I add across here, that becomes a -4. So I'm using a -3 and a -1. Okay. Then it looks like the previous problem, and I can set each of these parentheses equals to 0. Okay, we'll do this side first. Add 3 to both sides, not on the unit circle. Go ahead and make sure you're in radian mode, okay? And then if you can see here, remember when this is above 1, it's going to be a domain error anyway. Go ahead and do the inverse cosine of 3, domain error, so this one does not exist, okay? On this side, we can use our unit circle because we can add 1 to both sides, and we see that cosine of x is equal to 1. There's only going to be one place for that, and that's here at 0, okay? So then our answer would be 0. Now, if you notice up here, it says between 0 and 2 pi, but we do not include 2 pi in our solutions. If you remember from college algebra, the bracket means included, the parentheses mean do not include that value. Okay, this is the interval notation. All right, for number 8, again, we have another one, and we're going to solve between 0 and 2 pi. Their b portion is missing here, so we can solve this one by the square root property. Okay, isolate x. Add 1 to both sides. Okay, divide by 4. And then take the square root of both sides. When I take the square root of this side, I just get sine of x. This is going to be the same thing as the square root of 1, which is 1, the square root of 4, which is 2, and then you have to add the plus and minus on both sides. Okay? So where is sine of x equal to plus or minus 1/2? It's going to be in all quadrants. Positive 1/2 in quadrants 1 and 2, negative 1/2 in quadrants 3 and 4. So all we're going to do is use our unit circle and find all those locations. So 1/2 is here. We got in quadrant 1, pi over 6. 1/2 is here, 5 pi over 6. Negative 1/2, that's 7 pi over 6. And then negative 1/2, that's 11 pi over 6. So these are going to be all your solutions. Okay, number 9 has to do with this equation, basically about sunlight hours, which is L, and the amount of time, so daylight hours and time, right? And then here it says the number of sunlight hours during the day, and T is the number of days after June 21st. So T equals 0 means June 21st, and then so forth, right? During the first 365 days, when will there be 13 hours of sunlight? Okay, so now we're going to go ahead and solve for the nearest day, all right? So the first thing I'm going to do here is I'm going to go ahead and set this equation equal to 13, because here it says there's 13 hours of sunlight, and the LT refers to the amount of light. Now I only have one variable, and that's what I'm solving for. So I subtracted 12 from both sides, got this equation, and then I'm going to get rid of the 2.7 by dividing. So I get this equation. Notice that everything else is still the same. Now the only thing I can do here is take this cosine and take it over to the other side. So this is going to be our inverse function. That leaves all of this still together because you can't break it up as long as this cosine or any trig function is on the outside of it. Okay? So T, in this case, is going to be equal to the inverse cosine of 1 over 27, and then all I did here was flip it. So it's going to be 365 divided by 2 pi. If I put this in the calculator, you will see that there are 69 days after June the 21st. All right. Now, remember, cosine is going to be a positive fraction in quadrants 1 and in quadrant 4. So how can I get from quadrant 1 to quadrant 4? Well, if 69 days, and I'm going to go ahead and do this over here, okay? I'm going to do it like this. This is going to be represented by 69 days. All right, just like that. What I'm trying to do is find the other value over here that also has a reference angle of 69 days. Well, if there is a total of 365 days in a year, then I would say 365 days minus the 69 days. Okay, because one whole rotation, remember, one whole rotation is going to be 365 days. So if I'm looking for the angle from here all the way to this part, it's going to be the 365 minus the 69. Okay, so 365 minus 69 days, and I get 296. Okay. The way that I did it here was exactly the same thing, but I used it in quadrant 4. So if you notice here, I just made it 2 pi minus that, and then I did it a different way, but I still got the same answer. This is definitely an easier way to solve this problem. Let's do number 10. Number 10 says find all the solutions. So we don't have any restrictions, which means we have to write an equation. This looks like linear terms, so that makes it a little bit easier. I'm going to start with this, and I'm going to add 1 to both sides. Now you can see you have a 4x. Do not divide by 4 here. You can only divide when a coefficient is in front of the trig function, not after it. So I need to get rid of this cosine first by doing the inverse. Okay? Here I have 4x is equal to the inverse cosine of 1. Cosine is my x value, which occurs at 0 and 2 pi, okay, and so forth. Because remember, we're looking for all of the solutions. So 0, 2 pi, 4 pi, and so forth, okay. We're going to be using 2 pi. The next thing I'm going to do is set this equal together and then divide by 4 on both sides. Okay, so when I get that, I get x is equal to pi over 2. So x is equal to pi over 2 times n. Remember, n can be any integer. Number 11 says we're going to find all solutions of the equation in the interval. This is going to be a secant 2x minus 1. Answers are going to be in radians in terms of pi. First thing I did is rewrite it, and I isolated the x by adding 1 to both sides. Remember, don't divide by 2 because only coefficients before the trig function can be divided. Coefficients after the trig functions cannot. Okay, so take your secant over to the other side, which I did here. So the inverse secant of 1 is exactly the same thing as your inverse cosine of 1. Why is that? Well, remember, because those are flipped, and if I flip this ratio, I'm going to get this ratio. So these two values are exactly the same. Okay. Then what I'm going to go ahead and do is use my unit circle to determine where cosine is positive 1. If you remember, cosine is going to be positive 1 at your 0, your 2 pi, your 4 pi, and so forth. Okay. So what I did here is I started with the 0, and I said plus 2 pi times n, right? So you start here, and then the next one would be 2 pi. There's 2 pi. And then you would have 4 pi. So if n is equal to 2, you would have 0 plus 4 pi, and there would be your solution. When you get here, though, we're not solving for 2 of x. We want to just know what x is. I would have to divide everything by 2. So 2x divided by 2, x. 0 divided by 2, 0. And then 2 pi n divided by 2. The 2's will cancel out, and I'm left with pi for n starting at 0. So when I plug in a 0 here, I get a solution of 0, which is and does meet this requirement. And then here, plug in a 1, so I get pi. That's within the requirement. And then I plug in a 2, and I get 2 pi. But the parentheses means do not include the 2 pi solution, so we do not include this particular value. The only ones we're going to use is 0 and pi. Okay. All right, that concludes the 5.5 worksheet. Hopefully you're able to follow through with me. Let me know if you have any questions.